Hey folks, welcome to the channel. We'll be starting a new series in which we'll be solving CSES problems. The goal is to explain all the problems in such a fashion so that people are able to categorize their thoughts in a more methodical fashion and tackle problems easily. Goal is to publish 2 to 3 videos in a week so that you folks have ample amount of time to practice it. We'll be starting with the dynamic programming section, and the problem which we'll be tackling today is dice combinations. Let's move on to the logic building part first. We'll be seeing the solution on pen and paper, going through it step by step, and then and only then will we move on to code. So, what exactly is the problem asking? The problem is telling us that we have been given a number n and we have to obtain it by throwing a dice one or more number of times. Now, how can we achieve that? Let's break down the problem into simpler parts. Consider you threw a dice and you got any number. Since it's a standard dice, the numbers are between 1 to 6. So let's suppose you got 1. Now, if you could get n minus 1 more, the problem would have been solved. So one way is to get 1 and then add the number of ways by which you can obtain n minus 1. Similarly, if you get 2, you want to add the number of ways n minus 2 could have been achieved. And so on and so forth for 3, 4, 5, and 6. Now, how can we solve it? Well, we'll keep an array, let's name it dp, and dp of n would denote the number of ways you can obtain the result n by throwing dice, say, m number of times. So dp of n can be reached by 1 and n minus 1, 2 n minus 2, and so on and so forth till 6 and n minus 3. So we add the number of ways n minus I for all I belonging to 1 to 6 such that n minus I is greater than or equal to 0. Well, let's take an example. Suppose n was 3. You don't need 6 in this case, right? Because 6 is greater than 3. And that's why this condition n minus y greater than or equal to 0. Now, we ought to have a base case on which we'll base our addition. If you are given, say, the number 0, there is only one way to do it, which is doing nothing. So dp of 0 can be initialized to 1. Let's move on to the coding part. So here's the code. I am choosing C++ as the language for communication here. We'll take the number n as an input, initialize a dp array. Initially, every value will be 0 except for dp of 0, which is our base case, and that will be 1. I am writing iteratively here. A homework for you guys could be to write the recursive dp using memoization. There is one other subtask which I'll mention once we go over the code. So we'll iterate through the numbers one by one incrementally in the outer loop. And then in the inner loop, we'll iterate over the values which we could get if we roll the dice. So that's what we are doing here. If we see that number minus I is greater than or equal to 0, we'll add the number of ways dp num minus I to dp num. And finally, since the number of values can exceed int's range, we'll do a modulo operation and mod it by 10 to the power 9 plus 7. And finally, we'll print the result. Let's now submit the code and see if it passes. And it gets accepted. So the other task which I was talking about, apart from writing the recursive DP using memoization, is that if you see carefully, we are only using the last six values of DP. So for calculating DP num, in the worst case scenario, you need num minus 1, num minus 2, num minus 3, num minus 4, num minus 5, and num minus 6. Here, the space complexity of our solution is big O of n, but you can actually bring it down to constant space if you look at this detail. So another subtask for you guys is going to be to modify this code snippet so that it uses constant space and submit the solution. This code will be available on GitHub. I'll upload the repo and paste the link in the description below. Also, the notes will be present in the repository as well. Thank you for watching. Like, subscribe, and share with your friends in case they need it. And see you next time.